thanks for dropping in. A couple weeks ago, I released the design for this super clicky fidget button. This will eventually be part of a 3D printed puzzle, but I found that the button was pretty fun all on its own. And based on the many prints I've seen for this on Thingiverse, it looks like I'm not alone in thinking that. So I'm following up that design with a new fidget button. This time, based off of a toggle mechanism. This two-button mechanism is pretty delightful. Not only do you get a satisfying click, the mechanism leaps between click states in a way that feels like it wants to keep on clicking. If you've ever attempted to push a light switch only halfway, you'll know what I mean. Switches are designed that way for a good reason. And if you want to know more about why that is, the YouTube channel Technology Connections has an excellent video covering electronic switches, which you should definitely check out. But for this project, the leaping switch is there purely for tactile satisfaction. If you open the design, you'll see that the mechanism is really simple. In fact, it's simpler than the clicky pen mechanism I based my last button on. Each button is linked to the corner of this rotating cam. When one button is pressed, the cam rotates, forcing the third point on the triangular cam into a flat spring. When the cam reaches this halfway point, the spring, which was providing a slight resistance, now acts as a force to move the cam forward. This in turn forces the other button up with a satisfying click. Now the whole mechanism is prepared to go again, this time in reverse. Based on feedback from my previous fidget toy, I wanted to make sure that this mechanism was even easier to print. This design requires zero hardware, not even a metal spring. It also avoids tricky 3D printed threads. There are a few intentionally tight clearances, but they're in places that can either be sanded down easily or forced into place. For this you'll need to print a front case, a back case, a cam or toggle, two buttons, two small pins, and a small flat spring. For best results, make the spring completely solid. Ideally, it should be printed with long, continuous lines of filament, rather than the standard diagonal pattern that printers usually use for 100% infill. You can trick your slicer software into doing that by setting your perimeter count really high. 3 or 4 perimeters ought to do it. If oriented correctly, no support material is needed for any of these parts. The steepest overhang is the bottom edge of the case, and it's only 45 degrees. To assemble, press fit the spring into the back case. This will be a very tight fit, but a little force should fix that. Slide the cam onto the post in the center of the back case. The cam should rotate easily. Using 2 pins, connect both buttons to the cam. The buttons are not symmetrical. Be sure to orient them so that this chamfer is facing towards the center. Depending on your printer, you may be able to just force the front case on and be done. If the case is too loose, a little hot glue should work, but I wouldn't use much. Flipping the spring around every few thousand clicks gives the mechanism a nicer feel. And I'm sure eventually, maybe after tens of thousands of clicks, the cam itself might need to be replaced. So it's good to be able to still access this in the future. If the cases are giving you a lot of trouble, either because they're still too loose, or they're too tight to fit together, I've designed an alternate case that scraps the posts for bolt holes. Any M5 bolt that's at least 40mm long will work. Slightly thinner bolts would be fine as well, although it may affect the rotation of the cam. I've already printed half a dozen of these, and not just because the first few were just prototypes. Based off of limited marketing research, also known as a recent family picnic, the toggle switch is a hit with young nieces, nephews, and cousins. But don't worry, I haven't abandoned my original clicky button design. If you're planning to print one of these, here are some updates courtesy of feedback from your fellow makers. When choosing which cap to print, go with the one labeled Case Cap Looser Threads. The standard cap is too tight for many printers, but I've yet to hear of any issues with the looser cap. While my own prints didn't require any sanding on these parts that slide over each other, some people found that doing so has given them better results. If your slicing software supports ironing, which smooths the top layer of your prints using a heated nozzle, that can also help with the reliability of the button. Using a little wax could also help smooth out that motion. Printing the button with a different layer height than the parts it slides against reduces the likelihood that the parts will lock together. The functionality of the button may improve after clicking it for a while. I suspect that this is just moving the spring around until it finds a good position to compress reliably. Adding a short bolt to the cam could also hold a wandering spring in place. If a spring is too long, try adding a spacer or two. This increases the space the spring has. I hope you like this new design. I haven't decided how to incorporate it into a puzzle quite yet, but I'm growing certain that it's going to be the loudest puzzle I've ever designed. Do you also get the feeling that I need to continue this series with a button mechanism that has a purple and gray color scheme? Or is that just me? Well, until next week, Thanks for stopping by.